Hello, geometry students. As you are watching this, I'm probably driving through the middle of Virginia somewhere on my way back from visiting my family in Pennsylvania. Um, so I apologize for the stuffiness. I'm actually recovering a little bit from some type of sinus infection or something. But hopefully you can watch this, get section 2.5 without any problem, and we can pick up right back in class when I get back. So what I'd like you to do now is you can watch this video. You should watch with a friend, watch with your headphones. You can watch now in class or watch later when you get home. You will have homework that you will be turning in to me tomorrow based on these notes. But what I want you to do is to watch and just take notes. And this will be on Haiku forever. So if you ever need to go back and watch, I'm going to leave it up on Haiku, on our Haiku in Chapter 2. And as the year goes along, if I ever miss class, or maybe just sometimes just because, I will be adding to our Haiku pages and adding to the amount of video lectures that are on there. So anytime you want to go back and watch this lecture again, you can always go back to Haiku and watch it. Here's how this is going to work. I'm going to go through our notes on my screen. What you're seeing right now is my computer screen, and I will add to them. I will write on them. I will type some things down, and as I write things, you should write things as well. I apologize if the handwriting isn't exactly very clear. I'm trying to write with my mouse, so it's going to be a little messier than normal. But as I write notes, you should turn along with me in your notes and add to your notes. It shouldn't take too long. It's only 3 slides worth of notes. But as I write something down, you should write something down. And then if you hear me say anything that you feel like you might need to remember, you can write that down as well. So real quick, here's our first slide. Nothing on here that is too complicated or that you haven't really seen before. But now, instead of properties of algebra, as we learned last week, these are properties of segment congruence. So these are specifically dealing with segments and shapes, which is a little bit different than properties of algebra. Properties of algebra are what allow us to do mathematical operations in algebra. These are dealing specific with segment congruence. So you can see them there. We have the reflexive property, we have the symmetric property, and we have the transitive property. They are all the same as the reflexive, symmetric, and transitive properties of algebra as well. But now they are dealing specifically with segments, so the only thing that is different is actually their notation. So you can see their notation has changed a little bit. We have the bar over the top of each of the lengths because that is specifically indicating that it is a segment. We also have the congruent sign because when we're dealing with congruency, that has to do with shapes instead of specific number values as an equal sign does. Remember, when we use equal sign, we're referring to length or distance. When we use a congruent symbol, we're referring to shapes or actual physical geometric shapes. I would like to add another rule here, and it's not necessarily a rule, but it's something that is worth going over, and I'll show you what I mean. Like I said, this is not a rule. I'm going to copy this here. Let's see and I'll paste it down here. Good. If at any time in a proof you see something like this, and it says if, or let's say it says number 2, the second point in a proof, or the second statement in a proof says this, and then the very next point says, put a number 3 down here, says AB equals CD. Those are the same statements, but the only thing that is different about them is clearly one is dealing with segments and segment congruence, as we talked about a second ago, while one is dealing with the fact that because these segments are congruent, that means that their lengths are the same. And I want you to see that because it's an important distinction. These aren't exactly the same statement. They mean the same thing, but they're kind of saying the same thing a different way. This is saying this is saying that the two segments are congruent. Their shapes and everything about them physically is the same, while this is saying the actual number value that is attached to that segment are the same. The values are the same. So it's once again kind of hammering home that idea. And anytime you see this in a proof, the reason is always going to be because that is what the definition of congruence is. If two segments are congruent, then that means that the distance between the 2 points, the distance of the segments is the same. And that reason, so the reason for number 3 here, the reason would be that that's the definition of congruence. So anytime you see this, or you see it in reverse where it's AB equals CD and then it says AB is congruent to CD, or as it says it here, where segment AB is congruent to segment CD, and then the next step says AB equals CD, that's always going to be the definition of congruence. That being said, let's go ahead and jump to the next page in our notes, and we'll do this. We'll do this proof together. We are given that LK equals 5, JK equals 5, and that the segment JK is congruent to the segment JL. Remember, anytime it says anything about segment congruence, you should always go to the picture and see what that means. Here's what I'm talking about. LK equals 5. Well, I'm going to go over here to my picture, and I'm going to write that the distance between L and K is 5. JK is 5. I'm going to do the same thing. I'm going to write the distance between JK is 5. And it also says that JK is congruent to JL. Now, how would I add that to my picture? Here is JK, and what that is saying is that JK is congruent to JL. JL is a segment that we haven't talked about yet. Saying those two are congruent. Well, y'all should know by now how we are going to mark these two segments as congruent. We're just going to draw a tick mark through them, and that in my picture says these two segments are congruent. So now that we've added this to our picture, we can come down and we can see, okay, we've marked all of that. We've got a mental picture of what it should look like, and now I want to go ahead and look at what we are trying to prove. We're trying to prove that LK is congruent to JL. Once again, just so I know where I'm going, I want to go and look at what that means in my picture. I want to prove that LK, I'll use green for this, LK, this segment here, is also congruent to JL. So you may see right away how we're going to do that. It's not a very complicated proof. You may not see it, and that's okay too. Regardless, what we're going to go down is we're going to start going through our proof and writing these reasons down. So let's start with number 1 here. Number 1, LK equals 5. Well, clearly that was given to us, so that reason is going to be given. Looking at number 2, JK equals 5. That was also given to us, so that reason will also be given. Once again, I apologize for my handwriting, getting used to writing with the mouse. LK equals JK. Now, where did that come from? I want you to take a second or two. I'll give you about 30 seconds of just blank time in this video to think about how we got this. Now, remember, when we're doing a proof, we can only use arguments that we have already introduced into the proof. So the only two arguments we've introduced into the proof right now are number 1 and number 2. LK equals 5 and JK equals 5. So number 3 is coming from some combination of 1 and 2. Take about 30 seconds, maybe discuss it with the person next to you, maybe just think about it on your own and figure out where this is coming from. About 10 more seconds. All right. Well, I think it is pretty easy to see that because LK equals 5 and JK equals 5, that they will equal each other because they equal the same value. But what is the actual reason that we are able to write this statement? It's because what we really did here is we did substitution, and I'm just going to write S-U-B-S-T period, so I don't have to write out the whole word with my mouse. But the property of algebra that actually allows us to rearrange that statement algebraically is substitution. So that's going to be our reason. And look what we have here. Just like we were talking about earlier, we have one statement saying the lengths of these two segments are the same. We have the next one saying because their lengths are the same, that means these segments are congruent. That is going to be, like we said, the definition of congruence. That's just what congruence means. If their lengths are the same, then the segments are congruent. That is the definition of congruence. Wow, that was a bad E. See if I can, try again here. There we go. It's a little better. Still pretty messy, but that's okay. You can see my point. So here's where we're at in our proof. I'm going to scroll down a little bit. Actually, I will just make it. There we go. Well, maybe I need to zoom out a little more. All right. So now that we have gotten here, we are now at this point in our proof where we have gotten to this point. Okay, LK is congruent to JK. That's not what we want. We want to prove that LK is congruent to JL. So what else do we have to do? Well, we know that JK is congruent to JL. Now, notice how we didn't introduce this into our proof until now, right? This was given to us, but we didn't introduce it into our proof until now. Why is that? Well, it's because now is when it's convenient for us to use this. So clearly the reason is given. Why is it going to be convenient for us to now use this in our proof? Well, it's because LK is congruent to JK. JK is congruent to JL. And if we're trying to prove that LK is congruent to JL, it's clear to see that because LK is congruent to JK and JK is congruent to JL, that LK, segment LK, is congruent to segment JL, and that's by the transitive property. You could argue this was substitution, and I would probably accept that on a quiz or test, but this is just cut and dry, cut and paste the transitive property. Segment LK is congruent to JK, JK is congruent to JL, so LK is congruent to JL. That literally is exactly what the transitive property says. And there's our proof. We've gone through, said each of the statements, we added to our picture, we used substitution once, and then the transitive property to prove that LK, this segment over here, is congruent to JL. All right, so we got one more proof to go, and then we are done. This proof, we are given that Q is the midpoint of PR, and we want to prove that PQ equals 1/2 PR, and QR equals 1/2 P, and QR equals 1/2 PR. So let's just take a second. Every time we start a proof, we need to look at what we're given, what we're trying to prove, and look at what that means in our picture. Q is the midpoint, so here we have Q. What it's saying is that Q is the midpoint of this segment PR. Well, what does that mean? Automatically, lots of things should be jumping into your head. If Q is the midpoint of PR, we know what that means. Midpoint is the average of the x's and the average of the y's. So if this was on an xy coordinate plane, then Q, the x value, would be the average of the x values of P and R, and the y value for Q would be the average of the y values for P and R. And what we're trying to prove is that this segment PQ is exactly 1/2 the length of this whole segment. And then what we're also trying to prove at the same time is that QR, this segment right here, is exactly 1/2 of the full segment PR. Okay? So that's just the picture version of what we're trying to prove. I'm going to go ahead and erase all of this, and then we'll start with our proof. Now, notice that I left out the first statement in this proof. Well, where are we going to start? We're going to start with what we are given. So our first statement is going to be that Q is the midpoint of PR. And that's segment PR. And what's the reason we know that? Because it is given to us. Okay, so now we have a statement that says this: PQ equals QR. I think it might intuitively make sense why this is true. If you look at the picture, that if Q is the midpoint, that these two segments should be equal to each other. But what reason do we know that this is true? What tells us that when Q is the midpoint of a segment, that it's going to create two equal segments? Well, that's just the definition of what midpoint is. Once again, forgive my handwriting here. There we go. That's just the definition of the midpoint. So PQ equals QR, we know that's true because that's the definition of what a midpoint is. Okay, so now we're on to statement number 3. PQ plus QR equals PR. Well, anytime it says something like that, it's kind of going to look like it's written in a different language. That's because it is. It's written in the language of math. So we need to always take this and look at what the physical version of this looks like. What this is saying is that this segment PQ is plus this segment QR is equal to this greater segment PR. Does that sound familiar? It should, because that is the, and I'm going to type this in so that I don't have to write it, because that is the segment, let me stretch this out here, that is the segment addition postulate. That PQ plus QR equals PR. The two segments that make up a bigger segment added together will be the same as the bigger segment. That was kind of confusing, so I'll say that again. The sum of the two smaller segments, here we have two smaller segments, PQ and QR. The sum of those two segments together will be the same as this bigger segment. So that is the segment addition postulate. Now, remember, to get this, we can only use the things we've already introduced. We used number 1 to get number 2. So number 1 we already used. So we can kind of get rid of that in our brain because that gave us this statement. Now we're introducing this by the segment addition postulate. So we're going to use number 4, some combination of 2 and 3. Well, this statement 3 and statement 4 are the exact same statement except one thing is changed. In statement 4, instead of a QR here, we have a PQ. Why does that work? Well, if PQ equals QR, then in this equality statement here, anywhere I see a QR, I can replace it or substitute it with a PQ. So this reason number 4 is substitution. Substitution. Okay? And it's clear to see from there that all I do here to go from number 4 to number 5 is I just added these two PQs together. That's the distributive property of equality. Sorry about that. So that's the distributive property of equality. And then to get from 5 to 6, I want you to take about 10 seconds and think about how we got from number 5 to number 6. What math did we do, and what would be the reason why this statement in number 5, I'll underline it really quickly, this statement in number 5 becomes this statement. What is that reason? Take about 10 seconds. I'll give you 10 seconds. And that, of course, is the division property of equality. If you're looking at your screen like I'm crazy, I'll tell you what I mean. What did we need to do to get PQ by itself here? We divided both sides by 2, which is the same as multiplying this side over here on the right by 1/2, which gives us the statement PQ equals 1/2 PR. Now, here is the tricky part. I'm going to give you about a minute of just blank video time to figure out where this came from. And remember, we have to prove it. It's not just good enough for us to say, yeah, that's true because this thing is true. We have to say an explicit reason why. So look back through our proof and tell me why. If I know that PQ is 1/2 PR, I can just in one step so easily say that QR equals 1/2 PR. Take about a minute, talk about it with the people around you, and then I'll write the answer down in a minute. You've got about 30 seconds. Okay, minute's up. Now, here's the reason, and I'm hoping that most of you figured this out. If PQ equals 1/2 PR, well, remember, all the way back up here in our proof, we proved that PQ and QR have the same length. They are the same thing. So if PQ equals 1/2 PR, then I can substitute QR in for PQ in this statement, and it will be true because these two things are true. So that would be substitution, because I substituted PQ, or QR rather, in for PQ. And what we have done is we've proven both of these statements that we've set out to prove. We started with Q is the midpoint of PR. We've proven that PQ is 1/2 PR and QR equals 1/2 PR. I want you to think about what that means for a second, because it doesn't just mean specific to this case. What that means is that anytime I'm given that any point, whether it's Q, whether it's X, whether it's A, whether it's C, is the midpoint of a segment, that means that this statement here is true. Remember, when we prove something is true, we prove it in every single case. So anytime, and this should make sense to you, this shouldn't have been that hard to kind of understand that this would be true, but I want to kind of hammer home the point that anytime we've proved something, we prove it true for all cases. So anytime we have a midpoint of a segment, it means that the two segments that it creates are each exactly 1/2 of the full segment. All right, so that is it. That is our lesson for today. Your sub has homework, a worksheet for you that you are to take home and do for homework tonight and turn it in tomorrow. If you have questions, feel free to email me. It's not that hard of a homework, so you shouldn't have too much trouble, and we went pretty in-depth in our lesson today, but feel free to shoot me an email, and I will see you in class tomorrow. Thanks for paying attention, and I look forward to seeing you.